Hi, welcome back to the channel. In the last video, we looked at how to secure our data using encapsulation. We learned about how to create and execute our data like this. So in this case, in the encapsulation, I have shown you how to use a class and then use the data in public, private scenarios. So public is global, private is local, and if you don't give any specifier, it is package. So in this way, we have discussed about how to secure your data properly in a class. So today's concept is inheritance. So let me explain, let me give you a scenario where we use this inheritance or how we use this inheritance. Basically, when you're talking about applications, let's say games or apps or any other applications that you're working on, like websites, whenever, let's say in a game, you have a player and you have an NPC and you have monsters. So most of these classes must have or may have some kind of program or some kind of data structure, for example, in this case we have movement. Player has movement. If you're writing a program, if you're making a game where the NPCs can also move, you can also give the movement for NPCs, and monsters will also have the movement. So in this case, when you're talking about shared concepts, like when you're talking about this player class, NPCs and monsters, they have some kind of properties that are shared among themselves. So in these cases, what we are going to do is, instead of writing the same thing multiple times, we are going to create a base class like game entity. And in this game entity class, we are going to create a variable called movement, or a vector, movement vector. This movement vector will now be responsible for moving the objects on the screen. If you are moving a player, if you are moving an NPC, if you are moving a monster, this movement vector can move these objects. So instead of writing the same program 3 times, I'm going to inherit this game entity directly with the player. Understand? And then I'm also going to do the same thing with the NPC class and the monsters class. So this way I can write the program once and execute it on different objects. This is called reusability. Reusability is the concept which is mostly used in inheritance. The reason why we use inheritance is because we want to reuse the same program that is available in a class into other classes. So in these cases, we use inheritance. To use inheritance, we use a keyword called extends. This extends keyword will extend the data or the members of this class into these classes. Understood? So whatever this class has, variables, functions, anything that this class has, can now be directly used into player, NPC as well as monsters. So these 3 classes will be called as derived classes. This class, which has all the data, members and variables and functions, this class will be called as the parent class or base class. Okay, so extends is a keyword which will extend the data, members and member functions of base class to derived classes. Now, there can be multiple derived classes. There can be multiple derived classes like this, player, NPC and monsters. But there will be only one base class. Now, when you talk about this kind of scenario, there will be some problems. Like for example, some people say, what if I want to use only one class? I want to only extend this code, the game entity code, into player class. Then what? Well, in that case, it is called single inheritance or one to one. You have one base class and one child class or one derived class. In case if you want to inherit this game entity to multiple classes, in this case, it is called one to many, many derived classes. It means that. What if I want to create a program where I want to create a scenario like this? Let's say we have a class A. Okay, we have a class A. This A has some variables and functions. Now, this class A is extended to class B. Now, what happens here is all the data members and the member functions of class A can now be shared to class B. So I can directly use it directly into this class B. What if I extend this class B? What if I say class C extends B? In this case, whatever you have here is already able to use in B, is already shared to B. So now when you are extending this B to C, it is also extended to C. This level of inheritance is called multi-level. Multi-level basically means from class A to B to C. Now these variables and these functions, including the variables and functions of class B and class B, are also given to C. So C can directly use the variables and functions from A and B. Understood? So this is called multi-level. These types of inheritances are available in Java. What is not available in Java is multiple inheritances, which means you can have one base class. As I said here, you can have one base class and multiple child classes or derived classes. But you can't have two base classes that are shared to one child class. You can't have two base classes. What do I mean by that? Let's say I have class A and class B. Now, can I write class C extends A comma B? No, it's not possible. In C++ it is possible, but in Java it is not possible. Why? Because there are some encapsulation terms. When you are encapsulating, you have to keep in mind that your data is actually secured. So you can't just easily share it to everyone else like this. And also there are some problems with hacking and data leaks and everything. So Java is trying to avoid multiple inheritances. Multiple inheritance basically means you can inherit two classes directly into one class like this. Okay, two unrelated classes. They don't have any relation. They are completely separate classes, but now they are directly inherited into your class. In the previous example, I said A is shared to B, extended to B, and B is extended to C. In this way, you have multi-level, but this one has no relation. A and B are completely different classes, but they cannot be shared to C. So what can we do in this case? Well, in this case, we can only use multi-level. We can't use multiple. Java doesn't have multiple inheritances. We can only use multi-level. So what if I want to use the data members of B and also members of A? Then in that case, you have a workaround. It is called composition. Well, let me explain the property here clearly. So let's say you have class A. In this, you have X and Y variables, integer variables X and Y, and a function called function1. Now in the B, you have variables L and M, and you have a function which is called let's say Zn. Okay, so these two functions are now, you want to use them directly, you want to call them directly into C. So either you extend B or you extend A. You can't extend both. Understand? So what if I want to extend A, but I also want to use B? Well, in that case, we have composition. Composition means it has the data, or you can have the access of one class into another class. You have the access of one class into another class. That is composition. So what does it mean? It simply means I create an object here. And now, instead of directly accessing it, I access these L, M, and Z1 through this object. Okay, so this is called composition. Composition basically means when you are working and you want to use class variables and functions directly into your class, you can either extend one and use the object for another one. In this case, both of these scenarios, only the public and the protected, or you can say public and default specifiers, are shared. You can't share private in both cases. In this case as well as in this case, you can't share private variables. Only public variables can be shared. So in this case, the same thing happens. If it is default or public, it will be accessible here. The same thing here. If it is default or public, here it will be accessible here. So there is nothing that is stopping you from inheriting or using multiple classes in your class. The only thing that is stopping you is extends keyword. If you don't like it, you may just skip it. For example, I don't want to use extends keyword. I just want to use class A and create an object for this, and class B create an object for this. Yeah, it is possible. This is called composition. Composition basically means you are creating objects for two different classes into your class and directly accessing the data from that class into your class. Understood? So this is called composition. Some people prefer it, some people don't. It's just a choice. It's just a matter of choice. Okay, I would say use both. Let's say you have let's say extends B. You extended class B and create an object for class A. What is the problem in that? It's both are same. The way they are using is the same. Well, there is a problem while using composition. Composition cannot be overridden. I'll explain that in the next video. Composition cannot be overridden. What is overridden? Well, in this case, if you are extending B, you are directly able to access these data and functions into C. Now the problem here is when you are accessing this function into C, the function that is defined here will work exactly the same way as it is working in B. You get it? When I am saying, let's say, I wrote here system.out.println. I said this is a method in B. Okay, so when I said this, what happens is when I execute this function from object B or from class B, I will get this output, right? When I do the same thing from C, I will also get the same output. So what is happening here is I'm just inheriting it. I'm just sharing it, or you can say the class B is sharing its properties to C. It is not directly giving the giving away anything. It is just sharing it. So whatever is happening here will also happen here from here. Now, using overriding, you can override this method into your class. Let's say I want to say a different way. So void zn1, I want to say system.out.println. I'm saying this function is overridden. Now, what happens here? When I say overridden, overridden. So when I say like this, what happens is when I create an object for class B and call this function, this will execute. And when I create an object for class C and call this function, this will execute. There are two different functionalities of the same function. This is called overriding. So overriding basically means you have the functionality and you take the functionality from one class and you share it to other class. In this case, I can override the functionality from the previous class in my class. Okay, once again I'm saying you have the functionality in a class, in a base class. So as I said, when you are giving the properties, it is called base class. When you're taking it, it is called derived class. So any class that takes properties is called derived, and any class that gives properties is called base. So in this case, base is B and derived is C. Okay, so in this case, what I'm saying is the base class already has a functionality. This functionality can now be overridden or completely overwritten in my class, in this class. Okay, so this is called polymorphism. It's a topic which we'll discuss in the next video. For this is the concept of inheritance. Inheritance is all about sharing properties, sharing the data members and member functions of one class into other classes. Why we use it? Well, to decrease the program, to decrease complexity. When you're writing big applications, you might have similar programs used in multiple classes. In this case, instead of writing the program multiple times, you write a class that has all this shareable code which can be then extended to other classes. This way, you are decreasing complexity. If you have any problem in this program, let's say you have a bug, you know where it is. You simply go to that class and simply change the bug there. Simply change the code there. Instead of going through each and every class and change every code, then test it, then again check everything. Instead of wasting all your time, you can simply create a class called base class. This base class will have all the program which can be shared. This shareable program can now be used. Okay, this is called inheritance. So is this the only way? Well, no, this is not the only way. There are multiple ways of doing inheritance, but there are multiple different types of inheritances. As I said, we can have one-to-one, game entity to game player, or you can say game entity to monster or NPC, only one class. So you can have one class base and one derived class. One base class, one derived class is one-to-one. If you have one base class but multiple derived classes, this is called one-to-many. There are many derived classes, one-to-many. If you are sharing the properties in a step-by-step order, for example, A to B, and then B to C, and then C to D, like that. So in this case, it is called multi-level. You're going on multiple levels of inheritances. Then we have something called composition. Composition is a kind of inheritance where you are inheriting the properties from one class to another class. Okay, so either using object or using extends or using both. So by using extends as well as objects, you are able to directly access this data into your programs. Okay, I hope you understand this concept. Now let's go into the program. Let's see a program, how it works. Now, when I talk about programming, I always say that create applications, then create programs and all that. The reason I'm talking about these OOPS concepts is because next I'm going to show you a framework. A framework which is mostly used in game development or app development. We don't write programs from scratch. It will take a lot of time. So using frameworks will help you even further. You can even create a program from scratch without writing a single line of code. It is very easy. So frameworks are the future. So always learn frameworks, some kind of frameworks. whether you are using in Java or Python or C Sharp, learn some kind of framework. Okay, it will help you in the future. Now, let's get back to the concept here. Let's talk about inheritance. Okay, so in this inheritance demo, I'm going to create a main class, main function. In this main function, I'm just going to create a single class. For example, in this case, I have a class called game entity. Okay, so this game entity has public string name. Every entity has a name, and then public int health. Okay, every entity has health, and public int let's say attack. Every entity has attack. In this case, when I want to pass the data or when I want to give data, I'm using a function, a specialized function called constructor. Constructors are functions inside a class that has the same name as the class. This one and this one is the same. So the class name and the function name is the same, and these are used to initialize the data. When, for example, in this case, I'm passing the data from here, string name. So this dot name equal to name. Whatever the name that I pass here will be now sent to the class name. Now, when I say health equal to 100 and I say attack equal to, let's say 5. Okay. So now we have game entity that has a constructor. This constructor is taking a name. This name is passed to the strings, and then I also have health and attack. Now all of these are public. It is a bad way to write the code. Write private variables. Always give private variables. Now instead of writing like get public, get data, get name, get health, instead of writing all that, we have another way. You can create getter setters like this. So go to the source menu and click generate getters and setters. Here you have this, select this all, and when you open this tab, you can see you have get attack, set attack. You have get health, set health, get name, set name. You can pick whichever you want and you can just execute that. For example, on the left side, on the right side, you have this select, deselect options. Then you have select getters only or select setters only. You have specialized options for that. Or if you want both, you can just select all and click OK, can generate. And as soon as you click generate, the code is generated here. Get name, get health, set health, get attack, set attack. All of that is done. Now the class is ready. Let's extend this to other classes. Let's create a class here called player class. Okay. So as I said, I'm not going to write anything. I'm just going to extend this class. Extends game entity. Now, as soon as they extend this class, there is an error. It is saying always create a constructor because this constructor has some data which I need to pass. So I need to pass the data to this constructor. That is why I need a constructor here. So add constructor. In this constructor, I can directly give the data from here like this. So I can pass the data in the main function, and that data will be sent to the constructor through this function called super. What is super? Well, super is a keyword that denotes the base class. If you are in the derived classes, the base class of this derived class is called super class. Player has a base class. The base class of the player is game entity. The base class of NPC is game entity. The base class of monsters is game entity. So game entity class, for all of these classes, the game entity class is the base class, also called as super class. So when I create an object called super, it directly denotes to the base class of that class. So the player's base class is a game entity class. When I say super, it denotes to game entity class. So when I say super of name, it means it is calling the constructor from the game entity class. So what is the constructor of game entity class? This one is the constructor of game entity class in which we are passing a data. So we pass the data here and we create the player name. So now we save this, we go to the inheritance demo, and here we create a player. So player equal to new player. Here we send Suman. So this is my player, new player. Right. So this is our new player. Now, when I create a player like this, I can directly call the data from that player. For example, system out.println player dot get. As soon as I said get, you can see get attack health name. Where are these coming from? These are coming from game entity because player class has no functions. So the functions are coming from game entity class here. And as soon as I said set, immediately the functions will be changed to set attack health name. Right? So this is what we call as inheritance. Inheritance will make you share the data directly into other classes. So the data is coming from base class and the data is shared to child classes or derived classes. Okay. Now if I just execute this, I will see Suman. So the data is gone to the base class and then it is coming to the derived classes. Now, when you are getting the data back to derived classes, let's say I'm giving the name, right? Get name. So instead of saying simple name, I said to uppercase. I can simply say to uppercase. Where? In the game entity. Now, when I execute this program, you will see my name in uppercase letters. What if I want to use a capitalized case? Well, in Java, there is no capitalized case. You need to write a program for that. That is why we are using frameworks. In frameworks, we have functions for that. Okay, then we have get health. So we can also set the health and max health and everything like that, right? So all of that program is actually now in the game entity class. Now, what is the advantage of writing this way? The advantage of writing this way is instead of writing the code multiple times, I can write the code once and reuse it multiple times. For example, this is a player. Now let's create a NPC, a class called NPC. Okay. Now this NPC class is also extending game entity. So obviously there will be a function, constructor function called NPC, obviously. But instead of just using this class, I'm also adding some more to this code. So in this case, I'm having a enum. What is an enum? Enum is kind of an array which stores the data as strings. So I'm saying NPC type. This enum is an array. It's an array that stores the data as strings. So let's see. I'm using the NPC as healers, 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 guards, or healer guard. Then we have shop. Then we have anything else? Armory, like this. Okay. So this is called as array. Now, these NPC types will be given here. How? Like this. NPC type. Just pass the type here. In this case, I'm having a type. NPC type. So this dot type equal to type. Now, I already have all the program here. The game entity is already giving me name, health, attack, and everything. What I need to do here is just add one more getters and setters type. Just add type. Since I already have the type, so I don't need to set the type. I just need to get the type. Select get here. Select get, and set is already unticked. So just clear, okay, generate, and now we have get type. So now we have an NPC. So NPC will have these things. Now let's create a healer. Let's create a healer called what do we say? Okay, a healer, H-E-A-L-E-R, healer class. This class extends NPC. So obviously the NPC is extending game entity. The NPC is extending game entity. The healer is extending NPC. So obviously you have multi-level inheritance here. So when I pass a name in this constructor, that name will travel to the NPC class. As I said here, super means base class, the base class of this class. This class base class is NPC, so it will travel to the NPC. In the NPC we have constructor that takes two variables, name and type. This name is then sent to the game entity class and the type is assigned to the type variable in the NPC class. So when I create a healer, I save this, I go to the main function and I say healer, H-E-L-E-R, healer equal to new healer. Okay, now let's say Lisa, and this is NPC type dot healer. So immediately what is happening here is the data called Lisa is now traveling to NPC, from there to game entity and directly access it to name variable. Now if I say get name, what do I get? Come out healer dot get name. Immediately I will see Lisa. See, I said uppercase. Uppercase was set in the game entity class here to uppercase. So it is set in the game entity class. I'm not writing anything in the healer. I'm not writing anything except this get type in the NPC. So I said get name. Now, what if I want to get the type of the class? Let's say healer dot get, you can see attack, health, name, and one more type, get type. Now I'll see healer. Okay, so this is called as healer. So if I want to, let's say, add this to the code here, I'll just simply just put like this. That's it. So now we have Lisa healer. Okay, so this way you can create NPCs. It is very easy. You don't need to write the same program multiple times. So in the player, I didn't write any code. In the healer, I didn't write any code. Where is the code? The code is in the base classes. In the game entity class, this is the base class. And in the second base class, which is the NPC class, it has the code, nothing else, right? Now, when you create healer, when you create guard, when you create armory, when you create multiple quest giving NPCs, so all of these types are actually written in this way. We don't write the program multiple times. We just write the program once and extend it to whichever class we want. Okay, I understood. I hope you understand all of this. Now, what if I want to restrict the data to one specific class? Well, for that, we are using private. If you see, we can't access this type variable. Let's see. Let's go and type, use this type variable in the healer class. Healer is an NPC, right? It is actually extending NPC. So if I type, just say type, or this dot type, okay, it is directly saying get type. Get type is the function that is in the NPC here, get type. Why is it only accessing get type and not type? Because type is actually a private variable. You can see npc.type is not visible. It is a private variable, so it is not visible. What if I want to access this into child classes but not anywhere else? So what if I want to access this variable directly into child classes but not anywhere else? In that case, instead of using private, we will use protected. Protected is an encapsulation keyword which will allow us to access this one this variable directly into our uh, base class, I'm sorry, child classes, directly into our child classes. Okay, now you can access it. So you can say npc type dot healer. Okay, so instead of sending the type here, we can directly access the type here. Why? Because now it is protected. It is not private or public. It is protected. Protected basically means access the data directly into your child classes and nowhere else. You can't access it you can't access the data outside the package. You can only access the data within the package and within the child classes, means within the derived classes. So in the base class, whichever data you want to send or you want to share to your child classes or to your derived classes, we access it as protected. So instead of private, we can use another keyword called protected in case of inheritances. Inheritance basically restricts, or you can say protected. Protected basically restricts the data from accessing outside the package. For example, if I create multiple packages in this, let's say a package called dot entities. Okay, so in this package, I send all of these classes, this one and this one, all of this, excluding inheritance demo. I just send them references, no, resource, refactor, move. Yeah, okay. Move to entities. Okay. So I send every class directly into entity class, entity package. Now, when I want to access these entities, I have to call them from the package themselves. So what if I want to access healer, or say, let's say healer dot type? See, can't access it. Type is only accessible within the healer class. You can't access it. See, type is only accessible within the healer class. You can't access it outside the package. Understood? Why only healer class? Because this NPC class is having protected. The NPC is having protected variable. So since the variable is protected, it can only be accessible directly into the child classes and not outside anywhere else. Understood? What if I want to access the name of the healer? Still not possible. You can only access it through public. So using public will actually make it globally accessible. Private basically means local access only within the class. And if you want to like share it to other classes, you can say protected instead of private. Okay, so instead of public, we can use protected. Protected basically means only within the child classes. It works within the child classes. Understand? So this is called encapsulation and inheritance. Inheritance is a very important topic when you're talking about sharing or reusability. Reusability basically means writing the code once and reusing multiple times. Okay, I hope you understand this concept. Thank you for today. Thank you for watching. The next concept will be about inheritance. Overriding and overloading. So I'll show you what do I mean by this. What does it mean to override a function? For example, in this case, we have a function here called in game entity. Let's say we create a function here for like public void like attack. Okay. Now in this attack, I said some damage and I wrote some program here. In the player must be able to attack, but the NPCs are invincible. They must not be able to attack. So how can we make sure that the NPCs cannot attack, but the player can attack or the monsters can attack? So how can we make sure that the function that is written here works differently for different classes? So to do that, For flexibility purposes, we are using polymorphism. Polymorphism is a concept which we'll discuss in the next video. Okay, until then, bye. Have a nice day.